So, my name is Bastian Rauch. I'm working as aviation fuel expert at EASA, and it's my big pleasure to have the joy to have the flash talk after the lunch break, and then also to moderate the last panel of this conference. So I thought a little bit what to do, so we need to bring some energy and flash into it. So let's look at something that is old, well-known fuel. It fuels our aircrafts. It's a single point of failure, but we have to say it's really has tremendous safety records. Now we have a change, and what I want to do here is first make you aware about some new challenges that we are facing here as a sector, to also create some energy for you to already think about questions that you can then ask, not me, but the panel that's joining right afterwards. So directly submit your questions, and then don't worry, we have a great panel here that will be able to answer most of them. So let's move forward. So we are in a transition to using more sustainable aviation turbine fuels on the market. This is triggered mainly by sustainability. We saw during COVID that the aviation sector is vulnerable. There can happen things that really can have an immense impact, and if we would imagine some climate events, severe climate events, the first thing that people will look at is aviation and say, maybe we should stop flying. So there's a clear driver towards having more sustainable aviation. And a good means is sustainable aviation fuel. So we see here on the left the RefuelEU mandates. On the right, we see the ICAO tracker of SAF facilities that are being announced. And you heard it from the news, maybe you know it personally, to achieve the mandates is not easy. It's a big, big challenge. It's a big economic challenge too. So IATA estimates that there are 3,000 to 6,000 SAF SPC refineries required worldwide. So the first look on the map on the right side, you think, looks good. We have a lot of announcements all over the world, but when you think it should be like 3,000 to 6,000 dots, this is only a short starter, and that are announcement, not real planned facilities. And also you can compare to what we already have on the market. So we have 500 to 700 global refineries worldwide. So it's really way more refineries that are needed to produce the volumes of sustainable aviation fuel. If you wonder why so much more, the scale of a SAF refinery will be smaller. So you need to be you need to be closer to the feedstock, you need to collect the feedstock. That means also that we have certain challenges on the supply chain. So we have we need to connect the flow of feedstock to the refineries, then of the SPC/SAF, we'll speak later more about that, to the point of blending, where it is being blended with fossil aviation fuel. So we have pressure from sustainability. The sector needs to become greener. We have a big economic challenge worldwide to build these refineries. And then we see also that it's clear that it's quite cheap to produce fossil aviation fuel. The price for sustainable aviation fuel, so what is currently in the market is HEFA, is 3 times higher than the one of fossil-based kerosene. When we look on power-to-liquid fuels, which is displayed here, also has a certain mandate too, prices are 10 times higher. That's the reason why you have an extra sub-quota for power-to-liquid fuels, because on the market they would not be competitive directly. But power-to-liquid fuels can be way more feedstock independent. You need electricity, you need CO2 that you can take from a point source or directly by the air capture, and you need hydrogen that you can also produce, and then you cut the independence, you become independent from the feedstock. But 10 times higher price than fossil-based jet fuel. So this, keep that in mind. You will see it on the next slide. So we see the quotas for 2025. So the RefuelEU mandate started this year. It's 2%. It's 6% in 2030 and then goes up to 70% in 2050. That means we are not really in a change management position. We are already in the middle of it, or let's say some part of the industry is in the middle of it. So we have on the one hand the need to ensure operational safety to manage well what we are doing already. On the other hand, we need to prepare other actors for the right change to make it safe. So what are the challenges for safety? Honestly, we were not so much aware of it before we received a confidential safety reporting. This confidential safety reporting, you don't need to understand the graph on the left side, it's distillation curves. Maybe the only thing that you can see is you have gray area, that is how normal jet fuel looks like, and then you have a red line on the top below the dash line. That is what was being reported. That's clearly different. It was stated to be on spec, but the certificate that certifies that this fuel was conforming to its specification was false. It was offered 3 or 4 times, so there seemed to be a certain willingness to push that to market. And then when we, based on this confidential safety reporting, analyzed the situation, we thought, oh, there's an incentive for fraud. That's why I mentioned this price difference of 3 times for HEFA, for example, and 10 times for power-to-liquid fuels. So the big question is the system robust enough against fraud? How does the system actually look like? We know we have tremendous safety records, but we also know the supply chain is really complex. It's global. You see fuel being shipped from Asia to Europe, leaving being traded with several different ownerships and then being distributed within Europe. We also know that we have comprehensive industry standards. So we are not blank. We have good safety records. We have also industry auditing system in place. We see it here. We have JIC standards, and we have the general manager of JIC later on stage. We have EI JIC standards and a dedicated standard EI 1533 also for handling sustainable aviation fuel in the supply chain. So the conclusion here is an out-of-spec blending component. You will see that later. So when we speak about sustainable aviation fuel, honestly, that's a blending component. Will be detected with a high probability by experienced market actors. That's when we talk to the different fuel suppliers, they were not really concerned. It was also a fuel supplier reporting that they detected it. But we also know, talking to different market actors, that these industry standards, as they are best practices, they are voluntary, they are questioned by new market entrants. So we have best practices that are not being applied, maybe by everybody. So the question that we have right now, and the challenge that we need to tackle is how well will the system that is well established for fossil-based jet fuel handle situations with new unusual situations and integrate new market actors. We published in the beginning of this year a safety information bulletin that described the new situation that we are looking at in the aviation sector. We published also several recommendations for different stakeholders. And yes, as part of that, we looked at the challenge, and the challenge is on a system level. You will see it also later on the panel. There are panelists that you're not used to because the system just worked, and the system that just worked is described here. We have a refinery that is processing crude oil and is producing a jet fuel. This jet fuel is transported, is put into a fuel storage somewhere, in another fuel storage. Then it goes towards the airport, and this is actually where the EASA regulatory approach kicks in. We ensure that the fuel that enters the airport is uncontaminated and of correct specification. Also, inside the airport, it's critically observed if there's no contamination. The operators are only allowed to fly with a specified fuel. So this is all handled inside the airport. Looking now at the new situation, so what differs? Where do we see the difference that we need to critically investigate? So here we have new SPC plans. Here's just one, but please remember there will be 3,000 to 6,000 if we succeed. And then, as I mentioned before, the SAF, Sustainable Aviation Fuel, is not really a fuel. It's a blending component, so it must be blended. So we have a new process that was not part of the ecosystem before. We have blending facilities. And, sorry, here. So, and when you do the blending, you need to ensure that the fuel can be really used. So the samples after blending are sent to laboratories that then produce the certificate that specify that the fuel conforms to the blending requirements. If that is specified, if that is certified, the fuel is handled as a drop-in fuel, because if it's conforming to the specification, it's drop-in. That means it can be used like a fossil-based jet fuel. It can travel through the supply chain. There are no differences. So before, yes, sustainable aviation fuel is not a fuel. It's a blending component. You need to have it segregated, as displayed here. After blending, you can treat it as and it's treated as a normal conventional jet fuel. So if we look at the issue that we are facing here, we see that the key for quality control are actually the blending facilities. And that's outside of EASA regulatory scope. So we look at the aerodrome and everything that is happening here. Keep in mind, industry is active. We have best practices in place. So this is not a completely unobserved issue, but we have new actors. We can have unusual situations. We also need to be aware that the risk scales with the number of new SPC suppliers that are entering the market. And RefuelEU is forcing a lot of new actors on the European market. So we need to keep that in mind. Yes, so this was really to bring a little bit of heat into the room. I hope you have a lot of questions, so please already submit them to Slido.